Flops. What the hell is flops? Why should you care? You've heard the word flops, right? It's in the headlines. It's on GPU boxes. GPU, graphic processing unit. But do you actually know what it means? In 2025, flops is the new anchor. Just like megahertz used to be in the 2000s when we walked into a computer store, if you're comparing machines and don't understand flops, you're just guessing. Let's fix that. FLOPS stands for floating point operations per second. It's a measure of how many complex decimal calculations a chip can do in a second. It's not about raw speed, it's about computational power. Not simple additions. We're talking about the kind of math, AI, graphics simulations, sound processing, and anything with a decimal point. Think of it like this. We used to compare computers with megahertz. Then it was cores, then gigabytes of RAM. So we'd walk into a computer store and we'd know how to compare one with the other. Now for AI and real compute, it's flops. It's a bit like audio gear. People used to obsess over speaker wattage, 1,000 watts. But did it sound any louder or better than a well-tuned 200-watt system? Not really. You need to know what the number actually means, or you'll fall for the marketing. So let's look at the numbers in some context. Let me give you some real-world flops numbers. Now, these numbers get pretty big pretty quick. 1 gigaflop, 1 billion operations per second. 1 teraflop, 1 trillion. 1 petaflop, 1 quadrillion, and 1 exaflop, 1 quintillion. I have no idea what a quintillion is. I know it's big. Sounds abstract, so let's ground it. So your MacBook Pro with an M4 chip is roughly about 30 teraflops of power. Now, an M4 with a Max is many thousands of dollars. A top-end Windows PC with an Nvidia RTX 5090, roughly 100 to 120 teraflops. A pro-level workstation GPU like a Nvidia B200 that runs in a big data center, 20 petaflops. That's over 150 times more than your gaming rig or something that you could buy in your MacBook. A MacBook with an M4 chip with plenty of RAM so you can put your large language model on your machine is more than $6,000 AUD. An RTX 5090 rig is 7 to 10K AUD. A B200 server, one GPU is about 40K, and that's without the cooling and the power. And that's just one GPU because these come in servers and sometimes they got multiple GPUs in them. So one server, when you see these rows and rows of racks, are $300,000 or $400,000 a piece. So if your laptop is already pumping out more compute than a supercomputer from 10 years ago, that's highly likely. What exactly are data centers doing today? Keep watching. I'll explain why flops is the lingo you need if you're buying gear, building AI, or trying not to look clueless in a tech meeting. So flops is not just for engineers. It tells us how fast you can train an AI model, whether a machine can handle real-time video or 3D graphics, how much you're likely to pay per hour if you're renting compute in the cloud, and that's important because not everyone can afford these big computers. It's the new performance yardstick. Let's see how it works in the real world with use cases. GPT-4 wasn't trained on someone's laptop. It was trained across thousands of GPUs running at exaflop scale over weeks or months. Cloud companies like Microsoft and AWS are racing to scale flops faster than anybody else because AI is now limited by the compute. So next time someone says this machine can do 20 petaflops, you know that it's not just tech jargon. That's a measure of raw computational power that's kind of shaping everything from your smart speaker to self-driving cars. This is like the new anchor. If you know it, now you're in the game. Ignore it and you're just guessing. So flops. Now you know.